A Chinese scientist who says he created 2 gene-edited babies has been fired by his university and may face prosecution.
An international controversy over science and ethics. This is really a remarkable and controversial development. He helped make the world's first genetically edited babies.
He hasn't published yet in any journal. There's skepticism about whether or not this is true.
He Jiankui, with his video announcement on YouTube, shocked and horrified the international scientific community. Out there,
I think it's a step forward. I don't know if it's a step forward that we should have taken this early on, but it's going to be interesting to see where scientists...
Bell Works in Homedale, New Jersey was a nexus of the last great technological wave. As the former home of Bell Telephone Laboratories, it was a research and development hub for several profound innovations of the 20th century: cosmic radio waves, the transistor, the transatlantic telephone cable, and the first mobile phone. Humanity is on the precipice of a new technological wave that could transform the fields of medicine, science, and healthcare: human gene editing, and it was made possible by CRISPR-Cas9. Developed in recent decades, CRISPR is a powerful new form of technology that is not only a remarkable scientific breakthrough, but also a technological development that could forever change what it means to be human.
CRISPR refers to a family of repeating DNA sequences that can be used as a genome editing tool, allowing scientists to insert, delete, modify, or replace DNA, changing our internal genetic codes.
Although gene editing has been discussed since the late 20th century, it wasn't until 2012 that a group of scientists made a remarkable discovery: that the CRISPR-Cas9 system could be used for the programmable editing of genomes. This opened up a whole new realm of possibilities.
CRISPR's greatest potential lies in its ability to delete hereditary genetic diseases.
CRISPR can be used to delete or modify single disease-causing mutations in the genome of embryos. These edits essentially correct typos in the genetic code. The disease-free code would then be passed down to future generations through sperm and egg cells, thereby eliminating any faulty genetic codes in the germline. Executed correctly, this practice could eliminate genetic diseases such as cystic fibrosis, Huntington's disease, or Tay-Sachs. According to biochemist Fen Zhang, a CRISPR researcher, there are about 6,000 or more diseases that are caused by faulty genes. The hope is that we will be able to address most, if not all of them.
If you could choose the genes of your future child, would you?
There are also concerns that gene editing will be used to create what are known as designer babies, ideal, perfect children with pre-selected desirable traits coded into their genome. These kids would be stronger, faster, and smarter.
But gene editing has also proven to be highly controversial among doctors, scientists, ethicists, and politicians.
Much of that opposition has been based in the threat of long-term health repercussions and the possible dangerous ethical and sociocultural ramifications, namely the possible revival of eugenics practices and the exacerbation of social class stratification.
Any unanticipated negative effects, such as inaccurate target mutations or incomplete editing, are irreversible, resulting in mutations that could be passed on to future generations. Additionally, most genes have more than one effect, a fact that could lead to unintended dangerous consequences. Recently, some experts have warned that the advent of genetic modification has the potential to put us at risk of reviving eugenics by promoting the improvement of inherited human traits. This practice would likely erode our sense of common humanity and equal dignity. Perhaps the most detrimental societal consequence is the exacerbation of inequality. Gene editing of humans is a procedure which will only be accessible to wealthy, privileged individuals who are afforded the opportunity to edit their DNA and the DNA of their children.
This process of germline editing could create classes of individuals defined by the quality of their engineered genome. This may result in a widening gap in our society between the superhumans and the unimproved, the haves and have-nots, and the ideal and non-ideal humans, a fear articulated by the late Stephen Hawking.
It is due to these unknown social consequences that some scientists have called for a moratorium of gene editing until further research is conducted and additional regulations and policy are implemented.
One of CRISPR's original co-creators, Jennifer Doudna, is one of those scientists.
This raises a number of ethical questions that we have to carefully consider, and this is why I and my colleagues have called for a global pause in any clinical application of the CRISPR technology in human embryos. And this puts in front of all of us a huge responsibility to consider carefully both the unintended consequences as well as the intended impacts of a scientific breakthrough. Thank you.
As science and technology continue to develop, humanity must collectively grapple with these new challenges and questions through rigorous research, investigation, and self-inquiry.